We're starting chapter 24, which is comparing means. So now instead of just dealing with one sample, we'll be dealing with two. When we are comparing two means, it's not very different from comparing two proportions. So similar concept if you have two means as having two proportions. The difference between the two means is going to be mu1 minus mu2. Again, here I always recommend that we make the larger mean the first one and the smaller one the second one, just so we can deal with positive numbers, but it really does not matter if you do deal with a negative. The standard error is going to be the standard error of the difference, but remember we always add standard deviations, so it's the square root of the sample standard deviation squared divided by n from the first sample, plus the standard deviation of the sample squared over the sample size of the second sample. And then you take the square root of the whole thing. So that's our new standard error when we are dealing with two means. Because we are working with means, we're still going to be using the student's t-distribution. The interval will be called a two-sample t-interval, so before you check the assumptions and conditions, you have to state that you're going to be doing a two-sample t-interval. And then if you're doing a hypothesis and test instead, it will be a two-sample t-test. The two-sample t-interval is the difference between your sample means plus or minus your margin of error, where your margin of error is still your critical value, so t asterisk, times your standard error. For the hypothesis test, to do the two-sample t-test, you have to calculate, again, your t-score before you can calculate your p-value. So your t-score will be your observed value is going to be the difference between your two sample means minus the difference between the two known means. So this will be your null hypothesis, which in this case will always be 0, because we're always going to assume that there's no difference between the two samples. So again, mu1 minus mu2 will always be 0, and then divided by the same standard error. The tricky part here is with our degrees of freedom. Because the sample size does not have to be the same for both samples, it's really difficult to calculate the degrees of freedom. There is an equation. It is possible to do it, and this equation is found on page 562, and it's in a footnote because even the book doesn't expect you to actually calculate it, because again, it's a really complicated formula. It's not given to you. You'll never use it. So we still are going to have to know what our degrees of freedom are. The nice thing is, though, is that you're going to perform your mechanics on your calculator, and when you do that, your calculator will tell you what the degrees of freedom are going to be. And they will not always be a whole number. In fact, most of the time when you're dealing with two samples, your degrees of freedom will be a decimal. It does not work out to be a nice whole number. And that's okay. We expect that. But again, you're going to be able to get your degrees of freedom from your calculator. The assumptions and conditions are the same as before. Random, 10%, nearly normal, and independent groups. The nearly normal part is different from the proportions, but it's the same as it was in chapter 23. The only difference is the independent groups, which is the same as when we were dealing with proportions. So there's not a whole lot of new stuff going on here. So let's go ahead and look at an example. We're actually going to look at a couple of examples, but this first example is trying to determine if you should buy brand name batteries or generic batteries. So a test was done to determine which would last longer in minutes, and they found a smiley face. No, they found this table of data. So they found out that the brand name batteries lasted this long, and the generic batteries lasted this long. And they tested 6 each for brand name and generic. Now, what I would do right now is on your calculator, I would go ahead and type in brand name and generic into, if you have an 84, L1 and L2. If you have an Nspire, you would do lists and spreadsheets and label them however you want to, but I would type them in there. And we're actually going to do a two-sample t-interval to determine this. So the first thing that we have to do for this example is to check our assumptions and conditions. So we first need to check that the data is collected randomly. And in this particular case, it doesn't state that they're random, but there's no reason to believe that one battery life will affect the next battery's life. So we would be okay with the independence assumption, and we'd be okay there. So we would say that there's no reason to think one battery's life will affect the next battery. Then we have to check the 10%. 6 batteries is less than 10% of all batteries produced. And then we have to check our nearly normal condition, and we check that by checking the histograms. So the histograms for the brand name batteries looks approximately like this. It is kind of skewed, but it seems like it might be okay to go ahead and use the normal model. And then the generic batteries has a histogram that looks something like this, which again, same thing. But we'd probably be okay in assuming that it is normal data, so that way we can use the normal model. And then the last thing we need to do is we need to check that the groups are independent. So in order to do that, we just have to think, are the brand name batteries going to affect the generic? And as long as they're not produced together, and we would have 2 companies making them, there's no reason to think that the brand name will affect the generic. So for independent groups, generic and brand name batteries don't affect each other's lifespan, so we'd be okay here. So once our conditions are checked, we can go ahead and then do the mechanics. Remember that the mechanics are where we actually perform the calculations. And it's okay to go ahead and do the calculations on your calculator, but you still have to show your work. Since we're doing a confidence interval, I'm going to go ahead and say that we'll do a 95% confidence interval. That means that we're going to have the difference in our sample proportions plus or minus our critical value times our standard error. So then in this particular case, again, you would type the data into your calculator, and when you do it on your calculator, which I can show you tomorrow, you'll be performing a 2-sample t interval, and then we find out that the mean for generic batteries, because I'm going to make generic 1 and brand name 2, is 204.4 minus the mean for brand name, which is 187.4, plus or minus. Now, on our calculator, we find that the degrees of freedom is equal to 9.95. So, to find your critical value with 9.95 degrees of freedom with a 95% confidence level, we end up with a critical value of 2.23 times the square root of 14.6 squared over 6 plus 13.6 squared over 6. And this gives us an interval of negative 1.2 to 35.1. So that gives us our interval, so we have to show this work, but again remember that it is the interpretation that is most important. So our conclusion is going to be that I am 95% confident that the generic batteries last 35.1 minutes longer to 1.2 minutes shorter than the brand name batteries. The interval contains 0, so we can't claim that either battery lasts longer than the other one. So since we don't know that generic or name brand lasts longer, I say buy whichever one is on sale and costs you less money. Looking at a second example, we're going to do a 2-sample t-test. So the resting pulse rates for a random sample of 26 smokers had a mean of 80 beats per minute and a standard deviation of 5 beats per minute. Among 32 randomly chosen non-smokers, the mean and standard deviation were 74 and 6 beats per minute. Is there evidence of a difference in the mean pulse rate between smokers and non-smokers? And if so, how big? When they ask you how big, they are asking you to do a confidence interval. In this case, they didn't give us the data. So when we are performing this calculation on our calculator, we're going to choose stats instead of data. For this example, again, we would have to check our assumptions and conditions. I'm going to go ahead and say that we can assume that the conditions are checked, and we're going to go straight to the mechanics. But again, you would check the random 10% nearly normal and independent groups to make sure that the conditions are met. But we're going to go ahead and assume that they work. Because we're doing a t-test, the first thing we have to do is come up with our null and alternative hypotheses. So my null hypothesis is going to be that the mean for the smokers is equal to the mean for the non-smokers. My alternative, because we're trying to find out if there's a difference, we don't know if it's increasing or decreasing, just that there is a difference. So my alternative would be that the mean for smokers is not equal to the mean for non-smokers. Once we have our null and alternative hypothesis, we can go ahead and calculate our t-score. So our t-score is going to be equal to the difference in the two means. So the mean for smokers minus the mean for non-smokers minus my null hypothesis, which will always be 0 when you're comparing two means, divided by the standard error, which would be the standard deviation for smokers squared over the sample size of smokers, plus the standard deviation for non-smokers squared over the sample size of non-smokers. So this ends up equaling 80 minus 74 minus 0 all over the square root of 5 squared over 26 plus 6 squared over 32. So then we get a t-score of 4.15. Now that's a pretty high t-score, so it probably indicates that we're going to have a fairly low p-value. But we have to go ahead and calculate the p-value as well. So our p-value ends up equaling 0.0001, and this is with 56 degrees of freedom. And it's based off of a diagram that would look something like this. Because I do have a very low p-value, that means I'm going to reject my null hypothesis. So our conclusion tells us that because the p-value is so small, the observed difference is unlikely to be just from sampling error. Therefore, we reject the null hypothesis, and we have strong evidence of a difference in the mean pulse rates for smokers and non-smokers. All right, looking at a last example, I want to know how much of a difference in price there is in buying a used camera from a friend and from a stranger. I found this data where from a friend, people are paying that much money for a used camera, and they're paying that much money from a stranger to buy their used camera. So for this last example, we're going to go ahead and assume that the conditions have been met again. And again, we're doing a test, so the first thing that we need to do is come up with our null and alternative hypotheses. So my null hypothesis is going to be that the mean for your friend is equal to the mean for the stranger. And my alternative hypothesis is then going to be that the mean for my friend is not equal to the mean for the stranger. So then we calculate our t-score. So the t-score is going to be the difference between the two means. So the mean of a friend, which is 281.9, minus the mean from a stranger, which is 211.4, minus my null hypothesis of 0, divided by the standard error, which would be 18.3 squared over 8 plus 46.4 squared over 7. And this gives me a t-score of 3.77. Again, that's a fairly high t-score, so again, we're probably going to have a fairly low p-value. And in this case, the p-value is 0.006, and that is with the degrees of freedom of 7.62. And it's based off of a two-sided diagram again. And again, because our p-value is low, we reject our null hypothesis. So again, in our conclusion, we're stating that we're rejecting. It has to be based off of our p-value, and we explain what that means in context. Our conclusion tells us that with a p-value of 0.6%, which is small, we reject the null hypothesis. There is a difference in the amount of money you are willing to pay a friend than a stranger. In this case, we don't know if we are more interested in paying more for our friend than a stranger. We'd have to do an interval to kind of figure that out. But all we can tell here is that there is a difference. But that is it for all of chapter 24. It was just one video, not too bad, even if it is a longer video. I will go ahead and see you guys tomorrow, and I hope you have a great night.